Hello everyone, welcome to video lecture on software architecture and design pattern. Today we are going to discuss fourth module, interactive systems and MVC architecture. So in this model, we are going to discuss introduction to MVC architectural pattern, analyzing a simple drawing program, designing the system, designing of the subsystems, getting into the implementation of undo operations, drawing incomplete item for the design purpose, if there is an adding new features that we are going to discuss, and different pattern based solutions and examples of architectural patterns. So these are the contents of the fourth module. So we will discuss one by one. Introduction. In this chapter, we start by describing well-known software architecture. So we can call it as, or sometimes referred to as, an architectural pattern called Model View Controller or MVC pattern. So here what we do the next, we design a small interactive system using such an architecture, look at some problems that arise in the context and explore solution for these problems using design patterns. This is our next target to this. Finally, we are going to discuss pattern based solution in software development and other frequently employed respective architectural patterns. So this is the entire thing we are going to discuss throughout this model. Now we are going to discuss the MVC, Model View Controller architectural pattern. Actually, we know that this pattern, which divides an application into three subsystems called as model, view, controller. And here the pattern always separates an application object or the data, which is termed as, we can call it as a model, from the manner in which it is rendered to the end user. So this is called as a view. So usually we can call it as a model class, view class, controller class, and from the way which the end user he can manipulate it, so that is called as controller. So that this is the user, end user. So we can see this model is an application object, we can call it as an object, for example word file or excel or whatever it is, where we can modify or add the data, delete, insert, whatever we can do it. So that will be rendered in the, so which will be viewed in the view format, that is the view pattern or view class, we can call it as a view subsystem. So that can be, user can control it, or end user can control and manipulate the entire view through this, again, controller. So the user can control having the model to view. So this is the, so initial basic diagrammatical representation of model view controller. So MVC, which also provides a powerful way to organize so entire system that support multiple presentation of the same information. So that is the one of the very powerful way to having the this MVC, model view controller architecture. So another thing, actually the model which is relatively passive object which stores the entire data, we say that any object can play the role of the particular model. So view renders model into the specified particularly format. So that will be taken. In case in a typical application, for example, the changes, model changes only when a user input causes the controller to inform of the model changes. That will be taken it as into the account. So actually view must notified whenever model changes. So instance variable, the controller always refer to the model and view. So that will be communication between both view and the model. Both here controller and view to communicate with through the we have that is the user interface UI. This is means that user interface which is used by the controller to receive any kind of the input, and others used by view to appropriately particularly display the model, and even both purposes we can use it. For example, in a panel can a display figure or whatever it is, and also accept the point as an input through the mouse click. So now there are a lot of examples. We will take one or two examples. So example one, suppose that in the library system, so we have a graphical user interface screen. So using which users can place hold on a book. So this we have seen in the previous models, in the sequence diagram, plus diagram, and other things. So another graphical user interface screen which allows a library staff member to add copies of the book. So here that the two model can be coming into the picture. Suppose that a user views the number of copies, the number of hold on a book, and is about to place a hold on the books. So at the same time, the library staff member views the book, record, and adds a particular copy to that. So information from the same model, we can call it as a book. Book is one of the model, is now displayed in different format in the two screens. So the book is model which can be displayed in the two different screen, that is the views. So the two model so played a role in this example. Next example, example 2, is that a mail server. This is a common, we know that, all of you know that, that's the email server. A user logs into the server and look at the message. We know that always looks at the message in the inbox or mailbox. The second window, again user log into the logs into again the same mail server, and he will do at a compose a message, certain message or any image or whatever the greetings to the friend or anywhere. So here also in the mail server there are two screens from two separate views of the same model. Model is the mail server, same model, but one is viewing the how viewing the inbox, that is the mailbox who sent by the friend or others. We are looking into the messages, and this at the same time if you want to replay that one, we are replaying the composer message. So there are the two this is the thing that two screens from the two separate views of the particular model. So this is another example. So like that there are a lot of examples also there. Suppose that we have a plot of a pair of x comma y values in the graphical coordination point. Actually this is the collection of data point constitute a particular model, because we are x and y coordinate, when it is there an x coordinate values coordinate system, that x and y which is always going to make the entire this model. So this is the graph. We say that graph viewing software which provides the user with several output formats. So we know that is the well common, that is the pie chart, a line graph, bar chart, so and so, whatever the graph. So when the user changes a particular format, we say that particular format, the view changes without any changes to the particular model. So these are the some of the examples of this MVC architectural model. So now this is the implementation. So as with any software architecture, so we know that the designer need to have a clear idea about how the responsibilities to be shared between the subsystems. So that is the main thing here. This task can be simplified. So if the role of each subsystem is, we need to clearly define. So this is the implementation. So what are the subsystem? That is the task of the row or role can be clearly defined in the following way. One is the view is responsible for all the presentation issues, and the model holds the application object. Third one, the controller takes care of the response strategies. So this can be taken as the definition of the model will be as follows. So then the next slide, so we will see that the actual definition of the model classes. So this is the definition of the model will be as follows. One is public class model extends observable, and the rest part here code will be given, that is not required for this thing. Public change data, because we are dealing with the model classes. The code update data, set change, notify observable if the change the information. So here each of the views is an observer and implements update methods. So here public class view implements observer, again code public void update observable model object data. So which refresh the views using the certain kind of data. So here we say that clearly if a view is no longer, for example, interested in the model, so it can be deleted from the list of observers. That is the one thing. Since here the controller react to the particular user input, so they may send the message directly to the views asking them to refresh the their displays. So that's why we have taken the replace particular refresh the display refresh view using particular data. For example, suppose that we start a detailed list of specification, for example, stated clearly, so enough they can be classified as belonging to the particular three categories: model, view, controller. In general, there is always an initiation step, we can say operation of the particular what we done in the model part, or which we invoke the presentation. So what the here controller, the system should, when the request is made, actually part of the response strategy, and the controller always the manage this part of the particular stroke. So here the strategy may involve interacting with each user in terms and making changes to the particular application. So another thing here, clearly there is a lot of entanglement. So that is a lot of the things between three part of model, view, control, and its challenge is always keep everything is the separate part. The controller invokes the methods which are always provided by the model, so that the separation is relatively easy to implement. This method can be adopted. Another thing here, there can be a confusion around drawing line between the responsibilities of the view and the controller for reasons explained what we earlier. So likewise, whatever we keeping the business logic way in the library management, the logic way from the display, for example, model view separation can be tricky. So we can say tricky in situation where there is a close relationship between the always in terms of stored data and the methods for rendering it. So as we design, implement a case study in the following particular pages, we make decision as various situation arises. Although the philosophy behind this architecture is easily stated that details are best explained by the particular example. So this means that not always possible to have a clear, we say that a clean division of the component such that component are designated for the data input and the rest for the particular display. We say that therefore, so in case of definition of that one model class, that it is quite difficult to decide which particular component belongs to the usually controller and which one part of the views. And surely we say that view has display data in general. Some of its component are always having the mechanism for user input. So here actually the approach what we use to resolve this, we need to create a user interface. User interface is the must role in this in case of this kind of the architectures. So with the functionality to serve the purpose of the both view and controller. To display the component, we say that component will be available to the purpose of the both view and controller. So which views invoke the particular appropriate configure to pass the message appropriate subsystem. We say the system to subsystem. So like that. So event for the operations. So for example, like in the scrolling or in the graphical GUI, graphical user interface, which are handled by the views, whereas others will be handled by like that. We should insert, delete, modify, whatever that are sent to the controller. The controller will having all the details. Now we will discuss, so what are the benefit of model view controller MVC pattern. So there are 5 major benefit of MVC architecture, so that we have listed out here. The first one is cohesive modules. Second one is flexibility, and third one is low coupling. Fourth one is adaptable modules. Fifth one is distributed system. Now we will see that what is cohesive modules. So actually these are the major benefit which we have counted for the model view controller architectural pattern. So a cohesive, the name says that in the cohesive. Why this MVC architecture is cohesive? So we know that, so instead of putting some unrelated code, so we can take it as an example, display and data. So putting the unrelated code in the same module, okay, so we separate the functionality so that each module is cohesive. So because the meaning is that actually whenever the module wise, actually the whole work, we say that whole work or fit together well. So actually they are cohesive. So clearly, so a clear compressive or together, we can say that clear cohesive is nothing but so stick together. So all the modules is work here. For example, display and data, which will be stick together, so that we can say that this is the benefited from the major benefit of this MEC architecture. So we say that MEC is a cohesive modules. Okay. Next, the second benefit of the MEC architecture is very clarity, flexibility. It is which is flexible to all architectural usage or in case of any applications. So the model is unaware of the exact nature of the view, or we say that it's a controller. So it is working with it. So it's simply an observable. This adds the respective or supportive flexibility, so that we say that it is a one of the very flexibility in order to nature of the view or in nature of the controller. Whenever working it, whenever we observe that one, a complete MUC architecture pattern is flexible. So the third one is very important, that is the low coupling. So the here modularity, we say that modularity of the design, whenever the modularity of the design part, which improves the chances that component that can be swapped in, or we say that swapped out as the user or a programmer desires or expected, the desire or the customer expected or the programmer desires. So that we know that modularity design, each part of the architecture will be divided into the particular modular. So whenever one component will be required to improvement, so other will be dependable to another one. So each component will be, we need to swap it out sometimes as a designer, or we need to swap in sometimes their communication, or one object will be working interdependent to the another object. So another object will be working to the, so this class or subclasses. So the designer or programmer has to swap out in the architectural part. So whenever it is required, this is the very flexible, or we say that very beneficial to the when we applying or using the in certain applications of MEC architecture. This also, which also promotes parallel development, easier debugging and maintenance. Very important concept in the low coupling part. So which promotes always the parallel development will be in the component design, or the we say that particular architectural part. So similarly, debugging cases component was or modularity, if the our entire architecture we have to divide into different modularity, we say that we can debug it if there is any works in the one modularity or one component. So that can be easily debugged one by one things. Another in case of maintenance part also we can take up in the modularity designing. So actually, the low coupling is meaning that, which refers to a relationship which here one module interact with another module through a simple or stable interface. Whenever the interface is connected, stable interface is connected throughout these classes or subclasses. Whenever main class, what we define that. So that is the major thing, that we can, you can call it as one module is interacting to the another module. That's why we have taken swap out and swap it in case of component design. So that we need to take it as a low coupling manner. So that is the one of the added advantage of this low coupling in MVC architectural pattern. So next, followed by adaptable modules. So this we can see it as a component which can be changed with less interference. Less interference means less disturbance to the component to the rest of the system. So that we say that, which is the adaptable modules. So that one is also the one of the major advantage of the MUC architecture, that is adaptable modules, changes particularly in the one component to the another component. So with very less disturbing, very less changes in the objectives or subclasses where we declare as an interface cases. So next we say that next followed by distributed systems. So this we know that in a MUC pattern, so the object oriented concept we say we are going to deploying in on the web. So whenever we are deploying the distributed systems, which should be very helpful for this, one of the great benefit for this MUC pattern by applying that one. So here, since we know that modules are separated, it is possible that it is a it is possible that there are what we say three subsystems are geographically separated, whereas what we say we had in the model, there are three sub model, view and a controller. So because distributed system, we know that modules always are separated. So one module in the one client, so another one client can communicating to the another one through a server. So how remote in the Java, that is the method for remote invocation method. So through that we are going to communicate in the lot of communication will be happen in the distributed system. So that is the we say that one is the added advantage of model view controller. So finally, we say that uh, the major, these are the very major benefit of model view controller patterns. So other than that, there are a lot of uh, lower benefit will be having this MUC controller. So this will be the major benefited count. So now the analyzing a simple drawing program. So this is the case wise we need to study very depth in the MUC architectural pattern. So now we now apply the MUC architectural pattern to the process of designing a simple program that allow us to create and label figures. The purpose behind this exercise, so we say that there are twofold, two way we can see that. So what kind of the twofold here? One is to demonstrate how to design with an architecture in mind. Another fold, another case, to understand how MUC architecture is employed. So even though, as always, our design begins with the process of collecting always a requirement. We know that. So here the first fold, what is that one? So we say that to demonstrate how design with an architecture in our particular mind, we say that designing with an architecture in mind, we require that we start with a higher level decomposition of responsibility across the subsystem. So here very clearly mentioned that whenever we have a that high level uh, application or programs, so that architecture we are decomposing in the high level of the decomposition of responsibilities to the very clearly we have to say that subsystems. So this example is model view controller of the entire, if you consider as a three subsystem. Okay, so here the subsystems which are specified by the architecture, so that will be taking a complete responsible. So the designer get to decide which classes to create for which or for each subsystem. So here designer easy to get the what class is required, where to require, and what he need to decide, what he need to create, whether a class is required or not. So everything why we need to in a high level decomposition is required because of the responsibilities in case of all the subclasses, because designer will get a very help so that he can do all the whatever the things to do it. But the responsibilities associated with these classes must be always will be a, we can say that is a consistent. We cannot call it as it's not a consistent, but within the purpose of the model view controller subsystem, so that we need to take it into the part. So that is the major thing. So how you can, how to demonstrate, for example to demonstrate how design with architecture, what how we are going to carry out with systems and interface which are connected to the subsystems, and how we are taking to the for each subsystem, and how we, how the designer is going to create a respective classes and which and all. So this is the fold one, or we can say this is the one case of when analyzing a simple drawing program. So we should go with this is the one fold of that one. Okay, so now next one is the two-fold. Another fold, we say that another case to understand how MEC architecture is employed. So regarding this, what will we shall follow that one. The architecture somewhat we say that very strictly. In case that is, we will try to have uh, three clearly delineated system for the model, weave, controller, and later on we will also explore and discuss variations on this scheme. So here, so we say that the thing is, we need to have that we should follow the architecture directly he has given to understand how MEC architecture is employed. So we have to strictly follow that. What is that one? One is model, another is view and controller. So that we have to strictly follow it that, and always our design so begins with the process of always process of the collecting requirements, so that we should keep in our mind what kind of collection, so how you are collecting the requirement, so what the our designers where he can start and when he start beginning of the particular process, actually what and all the, for example, analyzing a drawing program, so what we need to take defining the what cases, so that we are going to take in the usually specifying that one, what we say that analyzing a simple drawing, so specifying the list of requirement you need to be considered, what we will call that is called a software requirement process or software that can do the following things. Whenever you are taking in the software part, defining the use cases need to be followed by use case for example how we are taking that use case will have a particular column wise actions, what is the actions performed by the what actor, and similarly with respective system responses, so that we have to take it in analyzing a simple drawing program. So that and all including before going to designing the system, we should clearly have the or the clarification of analyzing the system. So in the next video we will continue that analyzing a simple program. So next continued version of the first part is specifying the requirement, then followed by defining the use cases, that is use case table and all that we are going to study in the next video.